The carnivorous dinosaurs are some of the most memorable and fearsome of all extinct animals. Our next guest will lead us through the wild diversity of some of God's most amazing creations. From the largest land predators to ever live to chicken-sized raptors, they continue to excite our imagination and point us towards the cause of their demise, Noah's flood. Coming up next on today's edition of Origins, Dinosaurs, Tyrants and Terrors, with Dr. Marcus Ross. Hello, my friends, and welcome to Origins. My name is Donn Chapman. It's my privilege to be your host. During this program, we showcase interesting guests who present evidence from science along with other important facts validating the truth of creation and the accuracy of the Bible. Today's guest, Marcus Ross, has loved paleontology especially dinosaurs, since he was a kid. Growing up in Rhode Island, today he joins us to share some of his passion for dinosaurs. So how old were you when you started to be excited about dinosaurs, Dr. Ross?
Boy, I was 4.5 years old.
Wow.
And I distinctly remember where I was at the time. I was at my cousin's house, and he pulled out a record. You know, those were the CDs don't spin so fast, right?
Yes.
Yeah. Little black plastic record, and it was one of those read along and listen to learn how to read types of things. And he didn't have the book anymore, but he just played the record, and it was these dinosaurs, and they were roaring and crashing and screeching, and there was music going on and volcanoes blowing up, and I just was captivated. And from that point onward, I just had a singular focus that I always wanted to study dinosaurs and be a paleontologist.
Instead of growing out of that, you just went deeper into it.
That's right. Don't grow up, grow in, I guess.
That's awesome. So what exactly is a dinosaur?
Well, that's a good question. You know, a dinosaur, if you get your standard bag of dinosaur toys, there's going to be a bunch of dinosaurs in it, and there's going to be non-dinosaur things. And some of the non-dinosaurs are easy to pick out. A woolly mammoth and a saber-toothed tiger are not dinosaurs, they're mammals. But what about, you know, the sailback sort of thing that looks kind of like a big lizard with a fin on its back? Well, that's not a dinosaur either. Or what about the animals that lived in the sea, like the plesiosaurs and the ichthyosaurs, or the pterosaurs that are flying around in the air? But none of those were dinosaurs either.
They're not dinosaurs.
They're not dinosaurs. So a dinosaur is a very specifically defined sort of thing. It's kind of like saying, well, you know, what is a human being? Well, a human being is a mammal. Right. Mammals are animals, but not all animals are mammals. So you go from animal to mammal and on down the classification until you eventually get to something specific. So for a dinosaur, dinosaurs are land-dwelling animals. They are diapsids, which is a group within the reptiles that has a pair of holes in the back of their head for where muscles go to work the jaws. There's a pair of holes on the top of the head, and there's a pair of holes on the side of the head, all behind the eyes. And so that's a group. That includes crocodiles, dinosaurs, but also lizards. Okay? Yeah. So lizards aren't dinosaurs. So in order to be a dinosaur, you also have to be an archosaur. That narrows it down to just the crocs and the dinosaurs and the pterosaurs. One of the things that dinosaurs have that crocodiles don't is that dinosaurs stand upright with their legs immediately underneath their body, more like mammals do and birds. And so what we've got here is the femur, the upper leg bone of a Tyrannosaurus. We're looking kind of straight in at the hip, and that femur turns in a little bit to come into the hip bone, and that keeps everything in a straight line all the way down. Now, crocodiles don't do that, so in order to differentiate or distinguish between a crocodile and a dinosaur, there's some other physical characteristics.
Given the weight that it's holding, that's good engineering, isn't it?
It's fantastic engineering. And for something like T-Rex, which is going to weigh a few tons, right, that's still just being poised on two legs. Now, they're big legs, right, but they're just legs nonetheless. Now, once you're an archosaur and you know that you're either a dinosaur or a pterosaur or a croc of some kind, how do you know that you're a dinosaur? Well, there's several different important characteristics of dinosaurs. This humerus over here, that's the upper arm bone. Goes up from your shoulder blade down to your elbow. Dinosaurs have this peculiar little ridge that points towards their chest. It's called a deltopectoral crest, and it's named that because of the muscles that it connects to. The deltoid muscle connects to the pectoralis, which is the chest, and so this is the crest that helps to connect those two. If you got a humerus and it's got one of those, it could be from a dinosaur. Some other aspects are in the hips. Now, the hip of dinosaurs are made up of 3 bones, the ilium, which is on the top, the ischium, which is towards the back, and then the pubis, which is towards the front. Now, the femur, the leg bone, fits into this area right over here. That's called the acetabulum, the hip socket. And for dinosaurs, there's a hole in that. As the 3 bones join together, there's a little spot where they don't all form in together. And so if you find a hip structure in the fossil record that's got a perforated acetabulum, this little hole in the hip socket, it's a dinosaur. One of the more interesting ones here, too, is at the very end of the leg, the tibia, that's your shin bone. The tibia has an ankle bone down at the bottom that's connected to it. And that ankle bone is called the astragalus. Now, our astragalus is structured differently. We've got the same kind of bone, but it's in a very different place. The astragalus for dinosaurs has this wing that sticks way up on the front. So if you think of the tibia, the shin bone coming down, the astragalus is a bone underneath it that cups up on top like this. And all dinosaurs, whether it's a Triceratops or a T-Rex, all have this feature. So these are some of the things that when a paleontologist finds this, they go, that's a dinosaur. These are the things that unite them as a group, no matter how different a dinosaur they happen to be. So what we're interested in today is not all dinosaurs, but especially the meat-eating dinosaurs. Now, all dinosaurs are land-dwelling animals. They're all air-breathing dinosaur animals, and they're all what the biblical reference would probably be something beasts of the field, when God's talking about when he created animals on day 6. So where are dinosaurs found? Well, they're found in rocks, of course. They don't seem to have any alive today, which is sad for a guy like me. But when we think about the flood, and we think about the different types of rocks that are around, the dinosaurs are found in a group of rocks that we call Mesozoic rocks. We call them Mesozoic rocks because of the types of fossils that are in them, like dinosaurs and some of these other marine reptiles and the flying reptiles and things like that. And so when we divide the rocks of the world into the stuff that has fossils, that is pretty much this stuff. The Paleozoic, Mesozoic, and Cenozoic are the rocks that contain abundant fossils. I think that the Paleozoic and Mesozoic, which have our shellfish, fish, amphibians, reptiles, and a few odd mammals, those are the flood rocks. And most of the rocks above the dinosaurs that have a lot of different types of mammals but look a little bit more modern for us today, those are the ones that formed after the flood was over. So paleontologists and geologists divide out the rocks of the world into these units, but they get divided much finer than that, because in the Mesozoic you have Triassic, Jurassic, and Cretaceous. Oh my, right? You've got those 3 units that any kid who studies dinosaurs learns that the dinosaurs fit in one of these groups. I studied this sort of stuff quite intensely, and it turns out that even this division can be broken up into a lot more divisions. Okay. So, for example, when I was studying for my PhD, I focused on some of the marine reptiles, and they were found in this green section of the Upper Cretaceous, which all has a bunch of names that nobody can ever pronounce. But that's okay. That's what I got tested on.
I'll bet you can.
I had to know all of those and work in them. So the structure of the geological column is lots of fossils, dinosaurs in these, and certain dinosaurs in certain groups among them. And we know that from the relationship of those fossils and rocks from one place to another. So dinosaurs are based on hip structure. As far as one big group of dinosaurs is the ornithischians. Those are the bird hip dinosaurs that have your Triceratops, your Stegosaurus. They've got your duck-billed dinosaurs. All those things are on one side. The meat-eating dinosaurs and the long-neck dinosaurs are all in the other group called the saurischians, and you can see here those 3 bones that we were talking about in the hip, the ilium, the ischium, and the pubis, and all of the long-neck and meat-eating dinosaurs have the same basic hip structure to them. Okay. So the defining traits for these guys then, lizard hip dinosaurs, if we're thinking about just the meat-eaters, they're lizard hip dinosaurs. They don't have a predentary bone. That was a bone that the other side of dinosaurs have. It's way out at the edge of their chin. And so we've got the 2 big groups. So what I want to do is start taking us on a bit of a tour on a couple of these things.
Take us up to the board to take us on a tour.
All right. So the meat-eating dinosaurs are in a group that we call theropods, and it means, kind of means beast feet. So some of the things to talk about. In South America, one of the most unusual of all the theropod dinosaurs is out there. It's named Carnivorous. Now it's called Carnivorous because of these big horns that are up over its eyebrows. It was a pretty good-sized dinosaur, probably coming in about 30 feet long. Wow. So not to be trifled with. But what's really weird about Carnivorous is kind of like T-Rex. It's got these puny little arms. Yeah. Really, really tiny. In fact, his arms are proportionally even smaller than T-Rex's are. Instead of 2 fingers, like T-Rex has, Carnivorous has 4. And so it looks like a regular hand, except for it looks like the hand of the wrong dinosaur on this big thing. Or perhaps we might think of this in terms of creation, of what's happened since the fall. It could be that we're looking at, an animal whose history since creation has resulted in a lot of degeneration. There might have been some mutations that had built up and not getting knocked out, and so it ends up having these really small arms as a result. Pretty fearsome predator. Baryonyx gets its name from this giant claw that's out on its thumb. The name means heavy claw, Baryonyx, for that. What's really neat about Baryonyx is its mouth and face are really long and narrow, almost narrow like a crocodile's. Yeah. And it's got a lot of very small teeth. And anytime a paleontologist or a biologist who studies ecology sees an animal with a lot of small teeth, it's a pretty big hint for us that it eats fish. Okay. Because fish are slippery. Which would go with the claws, too. Exactly. And them, yeah. They seem to be found in what look like riverbank sediments and things like that. So it was hanging around rivers going after some type of fish-like animal. This is one of my new favorite dinosaurs because this is Ebenezer. This is the Allosaurus that's now on display at the Creation Museum in Kentucky. And I got a chance to snap this picture before Ebenezer went on display. And Allosaurus has been known as a dinosaur for many, many decades, over a century. It's one of the most abundant in North America. It's found along the flanks of the Rockies. And what's interesting here is that you've got a whole bunch of holes here. Now, can you give me a guess? Which one do you think might have the eye?
I'll tell you, it's a lot of holes in its head.
There's only one pair of eyes.
Only one pair of eyes. I guess I would go with the middle of the 3.
Right here in the middle.
I was going to go back one.
Oh, you're going to go back one over here.
Yeah,
okay,
I kind of think that one.
All right. Well, you're right.
How about that?
So the eye goes in this. This is called the, each one of these openings has the name in science we call fenestra, which means a window in Latin. And so this is called the orbital fenestra because it's the one that has the eye, the orbit in it.
Well, what do the other 2 do?
Well, the one that's in front of the eye we call the antorbital fenestra, which means the one in front of the orbit. So go figure. This is the nostril, or what we call the nares, because the actual nostril is made up of skin, and that's going to be out at the edge here. There's another window right over here, and that's called a maxillary fenestra, because it's in the maxilla, the bone that's holding the teeth of the upper jaw. And then back over here, remember I said that dinosaurs were diapsids. This is one of those pairs of bones on the sides that's holding muscles that attach down onto the lower jaw to help the lower jaw move up and down. The other pair from the top is up over here, hard to see, but it's on the top of the skull, so if you look down, you see it. So these are the 2 holes that make Allosaurus a diapsid.
Now structurally, is the idea of that it just makes the power of the jaw that much stronger, that it has double...
It certainly does. It does a couple of things. It helps provide more jaw musculature to go in here to give it a quick snap of a shut. Yeah. It's not the strongest bite. In fact, Allosaurus had a fairly weak lower jaw compared to some of the other dinosaurs. So it probably mostly bit down with the front, with the top front, kind of hatchet its way down. And so this allows for more muscles and bigger muscles to be found here. But also notice that there's just a lot of open space, because here you've got a head that's sticking on the end of a skeleton and the legs are way back somewhere. And so as a result, this helps to lighten the head. Oh. And you have a lot of sinus area, a lot of air space that flows through here. And so it's a less strain on the neck, because this animal is out perpendicular. So that's one of the ways when you think of an animal, it's on two legs like a dinosaur. It's all about balancing the weight in front with the weight in back.
Wow.
We'll see how that plays out with T-Rex as well, which happens to be coming up next. So with Tyrannosaurus rex, this is the skeleton of Sue that's on display in the Field Museum. And again, we've got our nares out front, our antorbital fenestra, the orbit, which is this really weird, exaggerated, almost B shape here, and then also the musculature out over here doing some really odd stuff as well. So also diapsid, but T-Rex's openings here are oriented differently. The bones grow differently. This is how paleontologists tell this is a T-Rex versus an Allosaurus, is that Allosaurus always has the air holes and the other things in certain places, and they're shaped certain ways. T-Rexes are same general location, but different shapes. Now, T-Rex, of course, is famous for having these really puny hands with just 2 fingers. But the head for T-Rex is enormous, and the size of the holes is not quite as large for the head as it is with Allosaurus. So if we just think of the difference between the two and go back here for a moment, lots of openings, big openings for Allosaurus, not quite as big for T-Rex. And that might be one of the reasons why the fingers are so small, because if it's all about a balance between the weight in front of the legs versus the weight behind the legs, if you let your head get really, really big, something's got to give. And so maybe that's one of the reasons why the arms are so small. It's all about distributing the weight and the balance. T-Rex was the largest predator in North America. The specimen in Chicago is about 40 feet long. The largest of all T-Rexes, about 42 in New York. But there were some other dinosaurs. Each continent seemed to have about one of its own biggest out there.
Okay, we've got to take a break, but we'll be right back. Don't you go away. We are back with Dr. Ross, and we're talking about dinosaurs. I'm fascinated by the difference in size, that some dinosaurs could be so enormous, but then there are smaller ones that are just as much a dinosaur. Tell us about them.
Just as much a dinosaur and just as ferocious.
Just as
mean.
mean.
I would, in some times I'd say I'd rather meet up with a T-Rex than a pack of raptors, and there's some reasons why. So with the Velociraptors, they're pretty small, but they tended to hunt in packs and groups, and we'll see some of the evidence for that as well. But they also would have looked a little bit different from what we're used to thinking. When we think of a T-Rex, you've got this big dinosaur, lizardy skin, and things like that. But when it comes to the raptors and some of the other dinosaurs that are similar to them, it's more like a nightmare chicken in terms of the way that they looked coming at you. So this image here by paleo artist Michael Shrepnick shows Velociraptor with a lot of feathers. And this has been the sort of thing that has certainly been very hotly debated as to whether or not dinosaurs had feathers or not. The evidence has been mounting now for a good number of years that in fact at least some of the dinosaurs have a good amount of feathers to them. The evidence for this is interesting because Velociraptor has been known to be a dinosaur since they were first discovered in Mongolia in the 1920s. Roy Chapman Andrews was the paleontologist who went out there, and he collected some of these bones. And in the late 2000s, some of the American Museum of Natural History workers pulled out some of these older bones from Mongolia, and what they found was fascinating. The upper bone here is the ulna. This is your forearm bone out on this side of your arm. And when they took a close look at this and scanned it using a 3D CAT scan, what they found is that there were a series of raised dimples, dots, that were fairly evenly spaced along the front end of the ulna. And what they realized is that these are very similar to the same raised bumps that are seen in birds at the place where feathers tend to come in close to the bone. Now, feathers do not physically attach to the bone itself. They're integument. They're more like skin in terms of where they're placed. But because some feathers are fairly large, and this lower image is from a turkey vulture, which has really big feathers, as the feather comes in towards the ulna, the bone responds by growing larger to act as a place for more muscles to grab onto that feather so that the turkey vulture can make the adjustments in flight. Now, not all birds show these dots, but all animals that have the dots on the ulna have feathers. Okay. And so going back to the evidence from Velociraptor, it looked like Velociraptor had feathers. Now there were some other critters that also had feathers, and Velociraptor was a little bit of a latecomer with respect to that. But this is a picture of a fossil called Microraptor gui. And in Microraptor, it's in the same family as Velociraptor, probably the same biblical created kind as Velociraptor. But this one was only about the size of, a turkey maybe, in terms of overall size. And what was amazing is, after the first fossils were found, new fossils like this one were found afterwards, and they had feathers on them. All these dark brown...
That's feathers.
That's feathers. And they look like flight feathers. They don't look like fuzz. They don't look like, frilly sort of stuff. These are feathers that are part of flying. And it even had feathers way out on its tail that probably acted as a bit of a rudder or steering device. Now, Microraptor was a weak flyer. In fact, it probably could only glide. But its body was covered from head to toe in this sort of stuff. And that was one of the ones that when I saw this published in the literature, and this is actually a very common fossil in China in the locations where it's excavated. So there's a lot of evidence for this. This isn't a fake or a hoax.
No.
There's literally dozens and possibly over 100 specimens of these out there right now. So that convinced me that yes, some of the dinosaurs indeed had feathers. And so a reconstruction of what Microraptor might look like looks like this. And there's even some paleontologists now who've been looking at fossils of feathers, both bird and dinosaur feathers, and finding evidence of some of the pigment cells so that you might actually be able to reconstruct these feathers and actually show, yes, that's where the light and the dark banding was on the feather.
Wow.
Preserved protein material. And we'll get into why that is really important for us creationists in just a bit. So Microraptor's got some feathers. Other animals that aren't in the created kind as the raptors but are somewhat similar to them, this is an oviraptor. Now they got their name from the same Mongolian expedition in the 20s because this animal was found near a nest, and so it was given the name oviraptor, which means egg thief. They thought the eggs belonged to a different dinosaur and that this one was, pillaging and stealing. Well, it turned out that these are probably their own nest. And in fact, now we know this is a new fossil of an oviraptor. Now, as I said, the velociraptors and some of the other ones are pack hunters. And the reason that we know that is because there are bite marks and claw slash marks on some other plant-eating dinosaurs, one called Tenontosaurus here, illustrated by John Sibick, that came from the raptors. But the raptors are pretty small. So a Deinonychus, which is about the right size for the Jurassic Park Velociraptor, is about the size of a man, a little bit smaller. They're about 10 feet long. Tenontosaurus is about 24 feet long. Now, if you think of an African elephant, they're not afraid of one lion.
No.
In fact, an African elephant isn't even afraid of a bunch of lions because they're just so big. If you're a big bull elephant, nobody bothers you. But if you're a juvenile elephant, you're still not afraid of one lion, but you are afraid of a pride.
Yes.
And the same thing happened with these velociraptors. This Tenontosaurus was taken down by tons of them because this is a little guy. It couldn't be one, it had to be a bunch. So that was part of the evidence that helped us understand that some of these dinosaurs, they're not all just lone, solitary things like lizards out, on a rock somewhere. These animals live in communities, they live in herds if they're plant eaters, they live in packs for some of them. There's even evidence that T-Rex was a pack hunter.
Oh.
In Montana, paleontologist Jack Horner, who really loves plant-eating dinosaurs and doesn't like T-Rex very much, and he says that to the news all the time, but he's blessed to live in Montana that has a lot of T-Rex fossils. He keeps finding them. His team found 5 juvenile T-Rexes in one location. Wow. 5. So T-Rex,
they were running as a pack.
At least maybe as young, and this might tell us something again about how they live. So, these animals are diverse, they are wild, and they might be bigger and more diverse and more beautiful than anything we'd ever thought before.
Amazing, and I understand what you're saying about the pack. We have a mission work in India above the buffalo gudgers, and I got to go on a place up into the mountains where really you don't usually get to go in the back of a truck. And the guide was telling me that we were trailing a black leopard. The elephants aren't worried about the black leopard, but the wild pigs that run in a herd, That's the only thing that will scare the elephants, and it's the pack mentality. So I can relate to that to these to the dinosaurs, and you don't want 20 different mouths coming to you at the same time. That's fascinating. But this is incredible information. It's at a level where our folks can get it and see what an incredible part of God's creation this was, and the fascination. I don't think it's ever going to end. I think there's always going to be people wanting to know more about this incredible, unique part of God's creation. Thanks for sharing with us.
Absolutely. So glad to be here.
Okay, I'm a meat eater too, by the way, and we're glad you're here, and we're glad you've been with us today. You know, my friends, God made the dinosaurs. He didn't make them billions of years ago. He made them, and most of them probably were with us until the flood, and then they were gone. It's an incredible part of God's creation. I hope this show's been beneficial to you. It's blessed me, and I hope you always remember that it's God's view that He created you. And that should be your worldview too. Hope we'll see you again soon here on Origins. And until then, God bless you, my friend.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file from our website at www.originstv.org. Or for a DVD of this series, you can order online or send a $12 donation to cover shipping and handling and write to Origins Program Number 1508, Cornerstone Network, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and financial support of you, our Cornerstone family.